Today we are going to be graphing systems of inequalities. And so the main thing is to either use the slope-intercept form or xy-intercept. So let's take a look at when we use which one. So whenever it is in the form of this, where we have y equals mx plus b, this is when I'm going to use the slope right here, which is the coefficient of x, the number that changes x each time, and I'm going to use that y-intercept, which is what the b value represents, because when you cover up x, you're just left with b. That's what we have here. So we'll start with -4. This is our y-intercept. And so I'm going to go down 4 spaces on this coordinate plane, put the dot there, and then use the slope. Well, the slope is 1 to 1. If you don't see a number out in front, it's just 1. And you write 1 as a fraction because slope is a ratio of the rise over the run, the change of y values over the change of x values. Once you got some points, you can just leave them as dots or dashes. And then from that point, let's go ahead and draw an arrow in which direction we'd end up shading. So these arrows signify that the line continues past this graph. This says y is greater. Greater means bigger. And so we want to go towards the bigger y values, because that's what it's saying. Y needs to be bigger. So if you go this way, y values are getting smaller. But if you go this way, y values are getting bigger. And so just put some arrows in the direction that you'd end up shading. Now let's take a look at the next one. This one does not have an x, so that means every y value is 2. So the y-intercept is 2, and no matter where you go on this graph, you're always going to have y at 2. So it's going to be a line that is horizontal. So I'll go ahead and extend this line. I'll extend it past the graph because I want to see the different regions, and I can't see the regions the way I've got it right now. So I'm going to extend this one as well. So it goes off in this direction. So you can see now we can see the different regions. So again, we're shading above the blue line. And let's take a look at our red line here. Y is less. Less means smaller. So that means we need smaller y's. Smaller y's go in this direction. And so when we go ahead and shade, we're going to shade in the direction that the regions agree. So they don't agree here, they don't agree here, they don't agree here, but they agree right here. And so that's the region that you'd end up shading. So right in this region here are where the answers are going to be. These points would give us true solutions for both inequalities. Well, let's take a look at the next one. This one, you just have an x. Well, if it's just an x, that means every x value is 1. So you go over to 1 on the x-axis, and no matter what the y value is, x is going to be 1. So it's going to be a dotted or dashed line. And that just symbolizes that the values for these x components, or this order, the ordered pairs that represent the line or the division mark, are not solutions. But the solutions are on one side, so let's figure out which side. Well, here it says greater, so this means we need bigger x's. And so the bigger x's are off in this direction here. See, if I had drawn or shaded on the other side, those would be smaller x's. Well, we start with the y-intercept on this next point here, or next graph. So this is my y-intercept. So I'm going down 4 spaces, putting the dot there, and then using the slope. Well, this time the slope is 2 to 1. So that means you're going up 2 spaces over 1 to the right. Up 2, 1 to the right. And that's what changes each time, is the graph goes in the positive direction. Positive because both the x and y values are increasing as you're going. See, as my x values get, or y values get bigger, x values get bigger. So both, it's called an increasing line. Now which way do we shade? Well, y values have to be bigger. That's what this means. See, it's open towards the y. That means bigger. And so we are going to shade towards the y values that are bigger, which are above the line. So where do we shade? Well, we end up shading right in between these 2 lines right in here. That's where they agree. Well, let's take a look at our next one. This one's a little different. We have, first of all, we've got just a y is greater than x minus 5. So that's not too much different, because it's just the slope-intercept form. And it's similar to that first one where we don't see the slope, so we write a 1. And so it's just a 1-to-1 slope going up to the right, and it's a dashed line again. And then from that point, we can go ahead and figure out the shading. Again, it's a y is greater than, so this means bigger. So we need bigger y's. And so we're going to end up shading off in this direction. Now let's take a look at the next one. This one's a little different in that we don't have y by itself. So here I would use xy intercepts. So 3x is less than or equal to 12, and 6y is less than or equal to 12. And then I solve. Divide by 3, I get x is less than or equal to 4. Divide by 6, I get y is less than or equal to 2. So x value is 4. So let's go ahead and write that down. So I'll put a dot here at 4 on the x-axis, and then a dot at 2 on the y-axis. So that's what these are, intercepts. And so now I'll draw the line. This is a solid line because it has a line underneath that represents that the points on the line are solutions. Now, which way do we shade? Well, you can either follow the x's or the y's. Let's follow both. X is less than 4. Less means smaller. That's what we want, is smaller x's. So smaller x's are off in this direction. Well, for the y values are less as well. So that means smaller also. So smaller means down. So either one would have sufficed us to figure out which way we end up shading. So the region that the two arrows agree for both lines is in this region here. Well, our last problem is similar to this one where we have xy intercepts, a great method to use. The difference is when we find this x component. So let's take a look at it. 8x is greater than 4. Let's set up the other one as well, 2y greater than 4. Well, when we go ahead and do that division, notice what happens here. I'll show that here by dividing by 8. So you see how you got a bigger number on the bottom? Well, that means that we end up having a fraction. X is greater than 1/2. That's okay, just go over 1/2 of a space. So whenever you get the number on the bottom being bigger, it's a fraction. Over here you divide by the 2, and you get y is greater than 2. 2 goes into the 4 2 times. So we go up 2 spaces, put it out there, and then use we'll just draw a line between those 2 points. So we can go ahead and graph or draw that line. It's a dashed line again, because it does not have the line underneath, and you read off what it says. Either value gives you which direction to shade. X is greater means bigger. And so we're going in the bigger x's and the bigger y's. So bigger x's are off in this direction, bigger y's are off in this direction. So either one tells you which way to shade. So you're going to shade up in this way, and this towards the right, to the right and up. Well, the next one, you don't see a y-intercept. Well, if you don't see it, then you could just add 0. So 0 is the y-intercept. And what does the line say? Well, it's a negative slope. Negative means you're going to go down and then to the right. So down to the right is what we'll do. Or we could go up to the left. That gets us on that line as well. Well, this is another dashed line. And we go ahead and draw the arrows at the end showing that it goes on forever, and it's a y is less. Less means smaller. So we need smaller y's is what it's saying. So smaller y's are down in this direction. Well, where do the arrows agree? Well, I see they agree right in this region here. And that's where we'd end up shading. So those are the types of problems you'll see on tonight's homework. Good luck.